Hi, welcome back to Moose and Chemistry. This is another problem with net ionic equations. Alright, what we have in front of us is a word equation. Iron 3 nitrate plus barium chloride yields iron 3 chloride plus barium nitrate. Alright, so the first thing we need to do is write our skeletal equation. So we're going to go do that. We're going to go Fe plus 3 NO3 minus 1 plus Ba plus 2 Cl minus 1 yields Fe plus 3 Cl minus 1 plus Ba plus 2 NO3 minus 1. Okay, so now we have that. But this is not correct, of course. So look, you have a plus 3 with your iron, and you have a minus 1 with your nitrate. So you have to crisscross those oxidation charges, and you're going to make this iron 3 nitrate. Okay? This 2 and this 1 are different, so we're going to have to, well, wait a minute, let me undo that real quickly. Sorry about that. Let's actually take care of that, and then this would be 3. This is Cl2. We only put the brackets if it's a polyatomic ion. Okay, then we crisscross the 3 here. All right, and then of course this nitrate is going to get the 2 down here. Now we've got that done. So the next thing we have to do is we have to make sure it's balanced. So we got 2 chlorines here and 3 chlorines there. So that means we need to put a 3 here and a 2 there. All right. Well, now we need a 3 here. And we have a 3 there that gives us that. And that'll give us 6 nitrates. So we need a 2 here. And we're balanced. So now we're going to look at our solubility rules. Now, when we look at the solubility rules, all nitrates are aqueous. They're all soluble. So we don't have to worry about that. So now let's look at the next compound, barium chloride. All right, according to the third rule of solubility, salts containing chlorine, bromine, and iodine are generally soluble. Important exceptions to the rule are halide salts as silver, lead, and mercury. Thus, silver chloride, lead bromide, and mercury chloride are insoluble. Well, barium's not in that list, so that means this is also an AQ. All right, again, here's chlorine again. And again, iron doesn't belong to a list of silver, lead, or mercury, so it's also AQ. And all nitrates are aqueous. All right, now let's do the CIE. All right. So now we're going to break this into 2Fe plus 3 AQ plus 6NO3 minus 1 AQ. Where'd that 6 come from? You got a 3 here and you got a 2 here. 2 times 3 is 6. All right, so let's keep on going. 3Ba plus 2 AQ. Plus, oh look, 3 times 2, that's 6. 6Cl minus 1, and that's also AQ. Yields 2Fe plus 3 AQ plus, there's 2 and 3 there, so that's 6. 6Cl minus 1 AQ plus 3Ba plus 2 AQ plus 6NO3 minus 1 AQ. All right, now we've broken them all into their respective ions. Remember that solids do not break apart, liquids do not break apart, gases do not break apart. The only one that really have to worry about is the aqueous. That's the one that's the ticket. All right, now, So let's go ahead and erase that real quickly. Get that there. Say goodbye to all that. All right, now let's do our NIE. So we're looking for our spectator ions. We've got to get rid of those to figure out what the net ionic equation is going to be. So the iron is AQ on the left, and it's also AQ on the right, so it cancels out. As a matter of fact, let's change colors. You know, we like changing colors on this one here. So let's see. Let's pick one. Oh, let's pick blue. That'd be kind of cool. All right, let's see what blue looks like. All right, so blue cancels out there, and blue cancels out there. Okay, our nitrates. Hey, they're aqueous on both sides. See that? So they cancel out. Just like this was aqueous on both sides. Our Ba, it's aqueous here and it's aqueous there. So it cancels out. And then our chlorines are aqueous on both sides. So it's also a spectator ion. So, wow, wait a minute. What's this mean? You know what? We don't have a net ionic equation. So you would just say nada. Or no net ionic equation. Or does not exist. That would be kind of cool. So you guys, listen, you be snarly. We'll see you back here at Moosing Chemistry.